Well, this is a 4-year course in ruminant nutrition for you in a couple of seconds. But basically what makes the ruminant or cattle and sheep and those types of animals' digestive system different from ours is the fact that they have a large chamber in the front of their stomach. You know, they talk about cows having 4 stomachs. They have this large chamber, the first chamber in the stomach, that houses a fermentation vat. It is filled with microorganisms, bacteria, yeast, protozoa, fungi, all of these wonderful creatures housed inside of the animal, and that actually helps that animal to digest things that you and I cannot digest. So the grasses, the non-protein nitrogen, all of these things that we can't utilize, cows can utilize it because they have that giant fermentation chamber in the front end of them. The rumen, as it ferments feeds that provides the food to the animal, actually produces waste products. And one of those waste products is actually captured as methane. It is a completely normal and completely natural process in all wild ruminant herbivores. The way that we measure methane production in the rumen is actually pretty important, and there's a lot of ways that we can do it. Traditionally, we have used things that you would call a head box, which is where you put the animal into some kind of an enclosure that either encloses the entire animal or encloses just the head of the animal, and we can actually use instruments to measure gaseous exchange between the animal and its environment. Alltech have actually developed a unique tool for doing that, and that's evaluating the feed that you would feed to your animals in the laboratory. So what we do is we essentially take what we call IFM, which is in vitro fermentation model. It's a model for the rumen of the animal that we do right here on the bench. And what that does is we essentially simulate the fermentation that happens in that first chamber in the cow's rumen. We have these glass bottles that represent the rumen of the animal, and we take some rumen fluid from the rumen of the animal and we put them inside of these glass bottles. We add some buffered medium and some feed that you want to evaluate, and we actually ferment these in a warm water bath right here. We are able to model gas production over time and monitor the disappearance of different nutrients in the diet, and very importantly for this, we can actually measure how much methane, how much CO2 and other waste gases come off of that process. A big focus of our research programs here at Alltech and with every research program around the world, I think developing feed additives for cattle knows now that you can inhibit methane to a certain extent. However, methane is still required for that fermentation to happen correctly. So when you push methane reduction to a certain threshold, typically above the 30% inhibition level, you will typically start to see negative effects on the digestibility of the diet, the performance of the animal. So it can be inhibited, but only to a certain extent. There are several probably well-known methods for being able to do that. Perhaps best known is some of the effects that you get from feeding things like fatty acids to animals. And what that does is essentially provides an alternative sink for some of the waste products that come out of rumen fermentation. There are several products that can do that. Some of the other ways that we can do that is by directly inhibiting either the microbial population or the enzymes that produce methane. So that is quite a popular method and quite an effective method of doing it. And the last one would be basically modifying the microbial population of the rumen away from methane production. So you can get microbial populations that tend to make more methane, and you can get microbial populations that tend to make less methane. It's one of the reasons why we get so much variation between animals in how much methane they make. So if we can coax the microbial population towards making less methane, then that is a perfectly viable strategy and probably one of the most natural strategies of reducing methane in the rumen.